Welcome back. This little session is about materials. Okay, it's not going to be too in-depth, meaning I'm not going to cover everything about ZBrush materials, but I'm going to talk to you guys about setting up a good working material and why I use what I use. Okay, so I think our demonstration model for this little bit will be the mermaid, just because she has some interesting kind of sculptural marks on her. I'm going to I'm going to hide part of it, and then we will look at some of the characteristics of materials kind of across her stomach and see how it reacts to light. Okay, so primarily I want to talk to you guys about how I build up this double shade material that I use for most of my sculpts in this course. Okay, and the thing about this is, let me dock the material palette over to the right. So we can look through all this stuff. So the double shade material is actually built up, as you might guess, of two shaders, right? So if we open modifiers where we find all the things to adjust for the materials, we have S1 and S2 right here. Okay, so I'll go through these in a second, but I want to essentially build up this from scratch and show you guys the difference between a number of different shaders that eventually lead us to double shade. Okay, so probably the simplest shader that we'll talk about is basic material. I'm going to modify this a little bit just to show you kind of the case of the pure diffuse shader, meaning it has no specular highlights. And when I talk about specular highlights, I talk about highlights that react to viewing direction, right? So as you change your angle on the model, the highlights change. That's a specular highlight. A diffuse highlight is independent of viewing position, right? So if you have a shader that is purely diffuse, and this one almost is, so we can look at the settings under modifiers, you can see that it's 80% diffuse, 12% specular, and 8% ambient. Okay, I'm going to get rid of the ambient and the specular component and show you guys the case of purely diffuse. Okay, and this is what I kind of try to avoid in my shaders for working, because this is the case which is actually very easy on the model, meaning that it hides a lot of the imperfections and actually is pretty flattering material for maybe final use, or depending on what you want to achieve. But as you're working, it doesn't really show the imperfections in your model very well, right? So as we just adjust our lights, you can see that as I move this around, we see good form, but we only see we don't see any of the really sharp highlights that indicate small plane changes in plane. Okay, and notice also as I rotate around, this is a purely diffuse model, shading model, because none of the highlights or none of the shadows change as I rotate my viewing angle around the model. Okay, and I'm going to turn this to a purely specular model, and you can see that as I rotate this, the light wraps around and moves from, say, the stomach, reflection on the stomach, around to the side, and around to the hips. And so it's really reacting to our viewing angle. Okay, so that's the difference between the two, and they're almost two independent channels of information that you can use to assess your model, right? So let me put purely diffuse back on, and I'm going to make this a little bit smaller, and I'm going to I'll turn perspective off, so all of these will be the same, and I'm going to turn material, and I'm going to go to color, fill object, and essentially fill the object with the basic material. Then I will do Shift S to make a snapshot and leave that on the canvas then. So I have a snapshot of purely diffuse sitting right there. Okay, so as we kind of evolve our shader into something that gets close to the double shade, we want to add a specular level, right? So the thing that you might just naively do is just start to turn up the specular. But the thing I want to mention to you guys about this is what's called building energy conserving materials, which means that you pretty much you want the channel, the combination of your channels, ambient, diffuse, and specular, to add up to 100%, right? Otherwise, it will be saying if you have 100% diffuse and 100% specular, it's going to be saying that what's reflected off the surface is 200% of what was incoming, right? So if your light is 1, this highlight that's reflected right here is essentially twice as bright as the incoming light, which is a no-no, and we really don't want to do that. Okay, so I'm going to turn this back to diffuse, and I'm going to change this to basic material 2. Okay, and I'll fill this on this guy. So this will remain the same. This is now basic material 2, and I'm going to make what an energy conserving diffuse specular balance, right? So the simplest thing would be to put 50% diffuse and 50% specular. Okay, so that's, and 0% ambient, and this is kind of that type of material, right? So you get a little bit of diffuse. Let me just have a look at the curve. So this is kind of what you want for a diffuse curve. You want linear, so essentially 0 to 1 as the angle of the model faces away from you, and the light angle of the light to the model faces away from you. And for specular, if you pull out the curve, this is the curve that determines how tight the specular highlight is. So as it gets broader and broader, it starts to approximate the diffuse highlight. But we generally like a fairly broad specular highlight to start with, right? Because it gives a little bit more read on what's on the side of the model. Kind of blossoms or blooms the specular highlight out a bit wider. Okay, so that's generally pretty good. One other thing I'm going to mention about specular highlights is down at the bottom of the material palette, there's a slider that's called Blend Phong Specular. And this essentially is a slider that changes the specular highlight calculation from what's called a Phong highlight to a blend highlight. And in general, blend highlights are a little bit better for approximating real-world materials, right? So they're quite a little bit more sophisticated than simple Phong. Depending on how it's implemented, it takes a little bit more time to calculate, but we're not concerned about that. In general, you'll also notice that it's a bit wider as I pull that slider. So mostly when I make my double shade material, I use the blend side of this. So pull this to 1, and it's a blend shader. Okay, and you can see the effect of tightening and softening the specular curve. Okay, so I will just leave it right about here. And we're, again, energy conserving because we're 50% diffuse, 50% specular. And I'll put this right next to our purely diffuse model. And you can see, let me just make a quick snapshot. And you can see that having a specular highlight gives an additional channel of information beyond just diffuse. Right, I'm going to slide this over here off the screen for a second. So we're just going to look at these two. And I will rotate my light around. Right, and you can see that a little bit of specularity goes a long ways. And just notice as we go up through here, you start to read a little bit more form across these surfaces. And I will make a modification to this in my double shade to get a little bit more than even we're seeing here. Okay, so let me bring this back. And the double shade is the next material I'm going to grab. I'll build this from scratch. So I'm going to grab double shade 1. And actually, while we're pulling out our material palette, just look at this. Double shade is this bright. Tri-shade is even brighter. And quad shade is even brighter. I'm just looking at the icon down here. And that's because these aren't energy conserving as the default settings are put into them. Right, so double shade is here. I'm going to fill my object with this. Okay, and you can see that it kind of does all sorts of stuff with the brightness, meaning that it probably is not energy conserving. And if you look at the values, 10% ambient, 50% diffuse, and 100% specular, that says to me non-energy conserving. And then we add on top of that our second channel, right? So S1 and S2 are essentially additive. So S2 is being added to S1 to make it even brighter. Okay, so right now they're just snapshots of each other. So pretty much what I want to do is I'm going to put in S1, I'm going to put my diffuse and specular, and in S2 I'm going to put additional specular, but no more diffuse. And then we're going to balance the two to give us the right energy conserving material. Okay, so let's just do this on both of them. S1 to 0 for ambient, S2 to 0 for ambient. And S1 I'm going to leave diffuse at 50, and S2 I'm going to turn diffuse to 0, so no diffuse contribution from S2. And now I just need to balance my two specular channels. Okay, so the first thing I'm going to do for specular is I'm going to go down and I'm going to turn this again to 1 in the Blin-Fong specular on both of them. So select S2 and do the same. Okay, you can see right now nothing really happened except it just kind of doubled up the highlight, and that's because the specular curve is identical for both. But this is where we actually want to change the two, and that's why we're using the double shader, is because real-world materials typically have a double specular highlight. Whether you can appreciate it or not, there's typically a broader specular highlight, and then there's a tighter specular highlight. In fact, skin behaves this way. If you're doing skin shaders for people's faces, typically the very fine, oily layer is a very tight specular highlight, and then underneath that there's kind of a broader skin specular that is quite a bit wider. So let's just do that. We'll put our broad specular in S1, and so under specular curve I'm going to take this and I'm going to make it out to something about like this. Okay, and right now we're really blown out in our highlights because we're at 100%. Right, so we need to drop this down to make it energy conserving. To do that, essentially what we're going to have once we take out our 50% of diffuse is we're going to have 50% to divide between our two specular channels. So pretty much I'm going to test maybe 30% in my broad specular and 20% in my second tight specular. So I'll take this to 20. Notice again I'm in S2, and this is a nice tight specular. I'm going to make it a little bit less tight than that, like that. So I'm grabbing the really fine controller and I'm bringing them up against the wall. Okay, so let's put this over here and see how this looks. Make sure that we're all okay for our specular 20% here. Add 30% so that it gives us 50% specular reflection and 50% diffuse reflection. Okay, and that gives us a pretty good material balance. And let's just look around this with our light. So what you get when you do this is overall we have what appears to be a little bit less brightness, because I think probably our broad specular is not as broad as this, and also part of its energy is being diffused, is being transferred to our tight specular highlight. So you can see if we look across the hips amongst these three shaders that on this one we have very broad focus, no specular term. On this one we start to get a bit of a specular highlight. In this one we have the same specular highlight plus a tight specular. Okay, so that's kind of the way the double shade is developed. And the important thing is really just to make sure that you have your energy conserved. Otherwise you're going to be too bright, and nobody likes shaders that are too bright. Because essentially what happens is if you turn your light to 1, put it at 1, the brightest spot you should get reflected should be at 1. So it should reflect 100% of the incoming light, and everything else should be less. And then you have a shader that reacts nicely to incoming light. All right, so I'm going to clear these other two. Hopefully looking at them convinces you that this type of setup with the double specular highlight gives you the most information about your surface as you read it visually. I'll put this down to 0.85. And actually, this default light comes with an ambient of 3, which I assume is about 15%, as far as balancing the intensity of the regular light. Okay, so just again a quick visual assessment. Look at all the form we can read off of this versus this versus this. Okay, so that's the point of using the double shade. You could extend it beyond this. There's tri and quad shaders, but those don't make any sense. Really, because 2 channels of specular is enough. And I'm going to clear off the others on the screen, and we'll just have a look at setting up some of the wax shading for this. And the wax shader is kind of the wax preview is new, relatively new, and it just gives a nice kind of feel to sculpt on. Is it energy conserving? No, it isn't, but we can use it anyways because because we can. So pretty much to get the wax shader to work, you have to enable the wax modifier at the top of your material palette. So if I turn this up to 100%, essentially turning this to 100% will enable 100% of your preview wax shading. Okay, so the preview wax shading has to be enabled in the render palette. And if you go pull down render properties, this button needs to be turned on. And you can see as I turn that on and off, it just gives me, turns the wax preview on. Okay, so to actually modify what you're seeing on screen, these don't do it. These temperature, radius, etc. The preview wax modifier settings come from down here, right? So you can change the temperature, and well, the strength. If I put it up to 1, you can see it glows, and temperature at 100 goes red. At negative 100, it goes blue. 0, it's gray. I put mine very low, just a slight tint to it, because that slight tint gives an additional kind of channel of information, right, that you can just read beyond the speculars. And then I set the strength to maybe half. And really what this does is, as you can kind of see, it does a pretty good job of lightening up the dark areas and the shadows with some extra kind of volumetric information about how thick the mesh is. So that's why I use the wax modifier, because I'm all about getting extra information about my surface visually. Right, so as I look at this, you know, the wax modifier just gives you a little bit of idea what the depth of the surface looks like. Combine that with the 2 speculars and the diffuse, and we can really read all the surface forms here, both imperfections and contours and kind of convexities and concavities, right? And that's really the point of this whole lesson, is to just get you guys set up with a shader that is effective for working and reacts to the lights. Right, so that's why we're using these as opposed to matte caps. I do have a matte cap in my quick modifier, and matte cap gray turns on with, actually I have to fill it if I want to turn them on. Normally I don't fill my object with material, but for this lesson I was filling it. So matte cap gray is also just a decent workhorse of a material for sculpting. Generally it's specular and broadly diffuse, totally non-reactive to lighting conditions because it's a matte cap, right? So that's the limitation of matte caps, but useful on certain instances. And in fact, if you want to just look at how your surface is going to be, is how it's going to read under a little bit more forgiving conditions than these tight speculars, then switching to one of those matte caps is a good way. Okay, so that's kind of the broad introduction to building up a good working material. Thank you very much.